Good afternoon, everyone. I would like to give you a presentation of what we have been doing with Biogents Traps for mosquito control, so for mosquito population suppression, and also some examples of where we actually have used mosquito traps, Biogents Traps for mosquito elimination. And so, just very briefly about who I am, I think you already saw me. This is me. I am a mosquito biologist. I have been doing this for the past 35 years or so. I've known the Biogens company from the day that it started because its directors are long-term friends of mine. We did our PhDs together at the same time, long time ago. And so I know how this company has been developing over the years. Myself, I've worked in many parts of the world. I've worked and lived in Africa for 11 years. I've spent 3 years working in the Maldives not so long ago. And it has only been since 2018, 2019, so 5 years, that I've been working very closely with the Biogents Traps. And that's what I would like to talk to you about this afternoon. You can see my logo here. It's K&S Holding. This is my company in the Netherlands. So I'm originally from the Netherlands. And I want to make clear upfront that I do not have any commercial stakes with Biogents. I'm not a shareholder. I have no direct relationship with the company whatsoever, except for the fact that I'm one of their distributors in some parts of the world, particularly in the Maldives, in the Seychelles, in the Caribbean. I have some islands. So that's the way I function with Biogents, but I'm not a representative of the company. So what you hear from me, what I'm saying about Biogents Traps, is my personal experience. It's not a commercial talk that I'm going to give you. I'm going to give you my story the way it is. And there's a few things that I would like to discuss with you this afternoon. One, why would we be using mosquito traps at all? What is the rationale for using mosquito traps and not using any other tool or any other thing that we have been using in the past? And then more specifically, if you are using mosquito traps or you want to use mosquito traps, then why choose the Biogents traps? I think that is an important question that we need to answer here. Third, I'm going to talk to you about how we can use these traps for mosquito population suppression. Basically, how do we get the numbers down? Now, in the past, I can tell you that Biogents traps, historically speaking, have been used a lot by researchers around the world for monitoring mosquito populations. So if there was a disease control program or any other way of using needing data on mosquitoes, Biogents traps have been used for this for a long time in more than 100 countries. So they're used around the world. I think what changed in the last, let's say, 5 years is that we have experience in now using the same traps that were used for monitoring, but now using these traps for actually bringing down mosquito numbers. And of course, if you're in the business of pest control, if you're in the business as a pest control operator, then you're not so much interested in mosquito monitoring. That would only be part of what you do. You're interested in offering your clients a way of actually getting rid of mosquitoes, of lowering the number of mosquitoes that potentially bite people. So you're more interested in population suppression than in population monitoring. And that's what I want to talk about. I will talk about some examples from the use of these traps in the Maldives and in some other countries around the world, just to show you how I have been using these traps, and that may serve as an example for you. And then I will move beyond islands, because I'm mainly going to be talking about tropical islands. But we are now also at the stage where we're moving beyond islands and using the traps in a different way, which I will explain to you. And then I'll end with a slide that is more futuristic, looking at the future of what mosquito trapping may bring for us all. And then obviously there will be at the end a Q&A session. Now, there's not such a big group of people in this audience I could see. So if you have a question in the meantime, just raise your hand, and then Pooh can stop me from talking, and you can ask your question as we go along. Feel free to do that. The story of why using mosquito traps is a story that goes back to this island. This is an island in the Maldives, and it's in the Ba Atoll. And it's an island which is about half a square kilometer. It's just over 40 hectares in size. And it's occupied by a resort, a hotel, which is called Soneva. And Soneva is now more than 25 years old, this resort. And from the day that the island started, it was an island full of mosquitoes. This is an island that many other hotel operators did not want to have because it had such a large density of mosquitoes. And so from day one, when they started occupying the island, they started fogging. They started fogging to keep mosquito populations under control. And they were doing that for all these 25 years. The issue, of course, that they ran into is resistance. So this is why at the end of 2018, they contacted me in the Netherlands and asked me to come out to the Maldives to see if we could come up with an alternative way of controlling mosquitoes rather than using the fogging. So if you go to these islands, they are very lush tropical islands. They are islands with a very suitable climate for mosquitoes. These islands are warm, these islands are humid, these islands have a lot of rainfall throughout the year, so lots of places where mosquitoes can breed, and therefore it is not surprising that on these islands you will find very large numbers of mosquitoes. And I can show you that in the video in the middle, which I made with my phone, as I'm standing in the jungle on this island and being attacked by huge numbers of Asian tiger mosquitoes. Now, obviously, if you run a 5-star resort, you cannot have these sort of numbers of mosquitoes bothering your guests. So you really want to do something about this problem. Most islands in the Maldives, and in fact, in most tropical parts of the world, the answer to this problem has always been what you see on the right, fogging. And this fogging is something that, as I said, was also being practiced on this island in the Maldives. And it has two major issues that we're facing with this approach. One is that, as I already mentioned, if you do this for a long time, you're going to end up with mosquito populations that are fully resistant to these insecticides. In other words, you can spray as much as you want, but you're not actually going to be able to kill the mosquitoes anymore. So that's one big issue. The second issue is, since we are using mostly synthetic pyrethroid insecticides, is that these insecticides are indiscriminate. They will also kill all other insects that are out there in the environment. And so we asked ourselves the question, can we replace the fogging with mass trapping? So we use mosquito traps in a high density, and we combine this with larval source management. So we reduce the number of potential breeding sites for mosquitoes, and in that way reduce the high burden of biting of mosquitoes without using any insecticides. So this was the question that we had in front of us at the beginning of 2019, so just 5 years ago. That fogging is having a very detrimental, a very bad impact on the environment is obvious, but there are good studies now to support this. And I will read out what this says here. In a study conducted by Lee et al. In 2020, where they applied pyrethroid fogging for mosquito control at 10 different sites in a forest situated in the state of Selangor, Peninsular Malaysia, it was observed that a total of 1,874 invertebrates, so that's insects, spiders, all these kind of animals, across 19 invertebrate orders disappeared across all 10 sites. In other words, these insects, these invertebrates were eliminated, were also killed from these sites. In other words, fogging has a huge impact on biodiversity. It is really negatively affecting biodiversity wherever we use it. Now, it is often being used in urban environments. In many tropical settings, fogging is used in the urban setting because that's where a lot of people live in a very small area that you can protect with fogging. But it's also being used on these very fragile ecosystems in tropical islands, which have a very unique biodiversity that is being destroyed by this fogging. So basically, what we're talking about is finding alternatives for fogging, and this is where trapping comes into place. So that answers my first question. Why would we use mosquito traps? Well, basically, we want to have something that can replace the traditional methods, let's say the fogging, so that we have a lesser impact on the environment when we use mosquito traps. There's a good reason also for doing this, because we want to prevent people from getting sick after they're being bitten by a mosquito. And I show you here on the left, I show you a long list of viruses that are being transmitted by the mosquito that you see here. This is the Asian tiger mosquito, a mosquito that is now found in many different parts of the world. It's the #1 invasive species on the planet. It's all over the place. It's also in Europe now in large numbers, transmitting a lot of different diseases. And as you know, for a lot of these diseases, we do not have any vaccines or we do not have any specific medications. So if people get infected by this, it has a huge impact. I can recall the enormous epidemic that there was of dengue in Bangladesh last year, where really very large numbers of people got infected and died as a result of dengue. So you don't want this for your clients, the people that you offer your services to. People should not get sick. That's one. And two, people should not get bitten. So these are the two things that we want to do with these traps. My story actually goes beyond just looking at mosquitoes. I always talk about the dangerous triangle. It's the triangle of mosquitoes. And then it gets interesting because I'm now talking about the surroundings of islands where we have coral reef ecosystems and we have marine life like fish. And there is actually a connection between mosquitoes and corals, believe it or not. And of course, there is the connection between mosquitoes and plastics and trash. And this is that triangle that I'm talking about. How does this interact? The interaction between mosquitoes and corals and marine life is very simple. If you're using the synthetic pyrethroids for fogging and through aerosols, through the drift of droplets of your fog onto the ocean, onto the lagoons surrounding these islands, you are having a big impact on fish. Pyrethroids may not be so harmful to humans, but pyrethroids are extremely toxic, extremely dangerous to fish and coral life. This has been well documented and well described. So if we fog, we also kill not just biodiversity on land, we also kill biodiversity in the sea. Secondly, if we have trash lying around on islands and this trash is breaking down into micro and nanoplastics, these end up in the ocean as well and get consumed by corals, which makes them die off. And then the third connection is actually between mosquitoes and trash. If we have lots of plastics lying around, if we have tarpaulins, if we have buckets, anything that can hold rainwater, tires, etc., etc., these will provide ideal breeding sites for mosquitoes. So trash, corals and fish, marine life, and mosquitoes are closely interlinked through what we as people do with our environment. On to the question of why we should be using mosquito traps. That's one. And then two, why would we be using Biogents traps? If you go online and you start looking at the range of traps that are available for mosquito control, you will actually find that there's quite a few of these traps out there. People have invented all sorts of different traps for mosquitoes. Everybody claims that their trap is the best, and nobody provides data. Nobody provides solid evidence that their traps are actually working. And I think in that sense, Biogents is really different from a lot of other traps because throughout time, it is not Biogents themselves who have been evaluating their traps, but it is researchers, independent researchers like myself, who have been testing their traps and have shown and have published the data that their traps actually work compared to other traps. So the choice for me certainly is that I can rely on Biogents traps because they have a proven track record of actually working in the field. And if you go to many other traps and you ask for the data, you will not get them. I can tell you honestly, the way I'm sitting here, if tomorrow there would be a trap on the market that is much better than the Biogents trap, I would shift. I would shift to this new trap. I have not the connection to Biogents in the sense that I have to work with their traps. But simply I can say that at the moment, it's the only trap for which there is enough evidence that they actually work in different parts of the world. The way that I've been using these traps, and I should say I've been mostly working with the Mosquitaire trap, and I think Pook has shown you this morning the different models of the traps that you have out there. So she has been showing you this trap, so I do not spend too much time in explaining how it works. But the reason for me to be using this trap in different parts of the world is that I've been using these traps running 24/7. So I install them on these islands in these places where I work, and the traps run continuously 24 hours a day, 7 days a week. So what I need is a very robust and strong Biogents model. And I think the Mosquitaire trap is one of the more robust and strong models that you can leave out in the field for a very long time. The traps, as has been said, as has been explained by Pook, are visually attractive. So the contrasting colors of the traps, they will attract the mosquitoes at a short distance and will bring them towards the trap where they can get sucked in by the suction caused by the fan. And we use attractants to bring in the mosquitoes over distance. And she will have explained to you, Pook will have explained to you the different attractants that are there, like the sweet scent and the mozzie bait, the different scents that Biogents has developed. And basically what I've been using in my work so far is mostly the mozzie bait, which consists primarily of lactic acid. And lactic acid is a compound that we have on our skin, that humans produce on our skin. And besides that, I'm not just using this lactic acid, but I'm also using carbon dioxide. Now, carbon dioxide is a very important attractant for mosquitoes. That's one. And two, it is a very difficult attractant to work with. This is not something you simply put in a sachet and you can put in the trap. If you want to use carbon dioxide, you have only two options. Basically, you have the option of using it from a gas cylinder, which if you are in Bangkok, it's not going to be very difficult because you can buy gas cylinders with carbon dioxide. But if you are working on a remote island somewhere in the middle of the ocean, then you don't have access to cylinders of CO2, or it would cost you a fortune to get them. So what we have been using instead is a method of using fermentation. So we use a mix of water, of sugar, and yeast. And if you put water, sugar, and yeast together, you get fermentation. The yeast starts to consume the sugar and is then producing carbon dioxide. And that carbon dioxide is what we then connect to the trap and use as the second attractant. And it's the combination of the lactic acid and the carbon dioxide, which is really making the difference. In fact, we call it a synergistic effect. So that the sum of what you get of the two independently is more than just adding the two catches of the independent attractants. So this is what we put out. And at the moment, as we speak, in the Maldives alone, there's about, I shall say, maybe 1,000 of these traps running on 11 different islands to keep mosquito populations under control. When we started this, we had no idea as to whether this was going to be the best trap for the job. And I'll give you some of the claims that Biogents makes. Biogents claims that these traps are 100% pesticide-free, which I must say is correct. There is not anywhere in the trap where there is a pesticide involved. They claim that the trap is specific for mosquitoes. Well, not always. Sometimes we also get some fruit flies. Particularly when you use fermenting yeast and sugar, you will also attract fruit flies, the small little fruit flies, to the traps. Having said that, in terms of non-target species like bees and butterflies and all the beneficial insects that you have in the environment, it is correct. It's specific for mosquitoes, and you will not trap the non-target insects. Easy maintenance? Yes, easy maintenance. I have on the islands where I work technicians that are servicing the traps, the traps, putting new sachets, making the traps clean, making sure that we have the fermenting sugar solution, and they can service up to 125 traps in a day if it's a team of 2 people doing the job. Biogents claims that these traps can operate for 5 years. I can agree, because I started deploying my first traps on that island that I showed you, Soneva Island, in June 2019, which is exactly now 5 years ago. And still the original traps with the original fans that were inside the traps are running on that island today. So that means I've had traps that were connected in June 2019, and 5 years later, the fan in that trap is still running, and it has been running for 24/7 throughout a 5-year period. Rainproof. Yes, these elements of these traps are IP55 or IP68, so that means that they're fully water resistant. In fact, in the Maldives, I've had occasions where traps got flooded. So we had a flood coming in from the sea. Traps were completely submerged in water. And then when I went there and I lifted the trap out of the water, the fan started running again. So a trap that was submerged continued running as soon as it got out of the water, which is quite incredible. Safe for children and pets? Well, there's very little that can harm anyone that is getting close to any of these traps, because the moving part, the fan, is actually inside the trap. So it's not that anybody can get, their hands hurt or anything else. No smell, no noise. True. If you use a new sachet of Mosibate or Sweet Scent for the first day, it will have quite a smell. You will smell it. But then after a day, that's when the majority of the smell from the start is gone, and you will not notice it. So even though the trap is running around your yard, around your garden, you will not notice the presence of the trap. No noise. The fan that is inside the trap is actually a fan that you can compare to something that you would have in your computer. So you don't actually hear the fan at all. It's very silent. It's very low in energy. Yes, it is very low in energy. In fact, a single trap is consuming about 3.6 watts. So let's say I have an island where I have something like 200, 250 traps running. The total consumption of energy of 200 to 250 traps is less than what I would have with a single air conditioning unit running. So overall, the energy consumption is actually very low. And then they claim that if you use these traps in large numbers, that you get more than 90% reduction in mosquitoes. Now, that sounds very nice, and this is something that we have been testing in the field. First of all, when we started in the Maldives, I wanted to know, are these traps, these mosquito traps, are they actually bringing in mosquitoes if we use them with the mosibate attractant and the fermentation solution? And what you see here, this is a single catch from one mosquito trap that had been running for 24 hours. So one day was catching close to 3,000 mosquitoes in a single trap. So clearly, to me, this was a sign that the traps are bringing in such large numbers of mosquitoes that if we start using these traps in large numbers, that we may actually start suppressing the mosquito population. And that's what we started doing. So what you see on the right, you see an aerial image, you see a satellite image of the island. And you can see it's a very densely forested jungle island. And I explained it has a lot of mosquitoes on it. And on the left, you see on the map, every red dot and every yellow dot is where we put one of these mosquito traps on the island. So in total, we stuck out 256 BG mosquito CO2 traps, which gets to about an average of 6 traps per hectare. The second trap that we used on the island is the GAT trap. And I'm sure that Pook has been showing you the Gravit Aedes trap also, which has a big advantage in that it is a passive trap. It is not a trap for which you need electricity to operate it, and therefore it's very easy to deploy it anywhere on an island or in any kind of setting. So basically, when we started, for every mosquito trap, we had 2 GAT traps in its immediate environment. And then we started trapping. And then whenever we serviced the traps, so basically every 3 days, we would go to all the traps, we would empty the catch bag, and we would start counting the mosquitoes. And so in the very first month, we caught on this island 113,085 Asian tiger mosquitoes with all these traps. And this is actually what a pile of 113,000 mosquitoes look like. Now, I often get the question, how do you know it was actually 113,085? Well, we counted every single one of these mosquitoes. So this was obviously a big job. It's not a job that any pest control operator would do. But the reason why we did that is we wanted to make absolutely sure that we measured the impact of putting out all these traps in the jungle so that we could use it as an example to demonstrate to people how you can use these traps to suppress mosquito populations. So this was research. This was not just operational stuff. It was research to show how these traps are working. And that's me counting mosquitoes. So based on all of these trap catches, we could then make what we call heat maps. And a heat map is basically showing you the density of mosquitoes over a given area. And if you look at the top left here of the image, you see July 2019, and you can see that large areas of the island were red. And red is a very high density, and green is a very low density of mosquitoes. And you can see that in July 2019, when we had just deployed all these traps, that large chunks of the islands were still having very high densities of mosquitoes. This was also rainy season, so there was a lot of rain, a lot of breeding, a lot of mosquitoes flying around. Mind you, from the day that we started the operation, we stopped fogging. So in June 2019, when we deployed the traps, it was the last time that fogging took place on the island. And now it's 2024, so 5 years later, and not a single day has this island been fogging since we put out the traps. And you can see what happened over time. If you go to August 2019, September, October, November, you see that over time, that more and more the red color starts to disappear and the island is becoming greener and greener and greener, showing that we have now a much reduced density of mosquitoes. And if we're talking about the Aedes albopictus, or the Asian tiger mosquito, the average reduction that we reached over time was 93%. If we're talking about the southern house mosquito, so Culex quinquefasciatus, the second species of mosquito on this island, we got to an even larger reduction. We got to 98% on average. I can show you this in a graph. And on this graph, you see that when we started on the 16th of June, this is when we started measuring in 2019, the blue line in the top graph, the blue line is what we had on this island, which is called SFR, Soneva Fushi Resort. And you can see that when we started, that the density of mosquitoes, so the average number of mosquitoes per trap per day, was very high. So we were on an average of 100 to 110 mosquitoes per trap per day. But the interesting thing is that within just a short period of a few months, we managed to bring this population down to very, very low levels. And you can see here, if I use my cursor, you can see here in this middle part, this is the dry season when the population almost crashed completely. Now, this small little peak that you see here in June 2020, this is COVID. This is the time when the island had no visitors. There were no tourists on the island, and that means that the electricity was shut down. So basically, the traps were not running in that period, and mosquito numbers started coming up again. But afterwards, we started again, switched everything on, and then we kept our mosquito population close to zero, and that continued until today. Okay, so this mosquito population is now completely down. It also means that we have no more complaints from guests. We have no more complaints from staff living on the island about mosquitoes biting them. The red line that you see here, which starts about a year later, is SJR, which is Soneva Jani Resort, which is a second island. So Soneva actually owns 3 islands in the Maldives. They also own Soneva Jani, so SJR. And you can see that over time, the same thing happened here. We deployed the traps on the island, had a very large density when we started in the beginning, which you see here. We got everything down nicely, and then we had this big peak. And this was interesting because this peak was the time when construction was taking place. A lot of building activities were being done, meaning that there was a lot of standing water around the island and all these construction sites. And that led to a peak in mosquitoes. But fortunately, again, we managed to bring also that population down. And again, until today, also that population on Soneva Jani is very close to zero. So that's for the Asian tiger mosquito. I can show you the same kind of graphs for the southern house mosquito, Culex quinquefasciatus, where you can see that decline was even more impressive. So when we started in June 19, very large densities, but we knocked that population over the head, and we did the same thing in Soneva Jani when we started there a year later. So basically, both of these mosquito species have been completely suppressed. Now, I'm talking about complete suppression, more than 90% reduction. But what would it take to actually bring mosquito populations down to zero? Would it be possible to completely eliminate mosquito populations? And that is the question that we asked ourselves on a third island where we started working. This is what we call North Island in the Nonu Atoll, also again in the Maldives. And you can see that this island in front here is actually a rather small island. It is only 3 hectares in size, but it had a very, very high density of both Asian tiger mosquitoes and Culex quinquefasciatus mosquitoes. And the resort would from time to time take guests out to this uninhabited island for picnics and for snorkeling and for swimming. And people were being bitten there like crazy on this island. So we asked ourselves the question, what if we start increasing our trap density to such an extent that we actually are able to eliminate both these populations. And that's what we started doing, and that's what you see in this graph. So the red line is showing you how we increase the trap density over time, so that eventually we ended with 10 traps per hectare. So for every 10,000 square meters, we would have 10 traps, which basically means one trap every 33 by 33 meters. That's basically where you will find traps. And you can see that the Aedes catch shown here in the blue line was initially, again, very high. But then as we increased to the level of 10 traps per hectare, that's when we started hitting zero. And basically, the last mosquito that we caught on this island was caught on the 20th of February 2022. So that is now close to 2.5 years ago. And this island has been free of Asian tiger mosquitoes from that entire period. So it's actually more than 22 months now. So that's eliminated. We eliminated mosquitoes from a small little island. And that meant that a lot of people now started to get interest in the approach that we had. First of all, after we succeeded doing this, we wrote a scientific article on the entire experience that we had with mass trapping for mosquito elimination on these small Maldivian islands. And this is an article that Pook has. And if you are interested, please ask her, and she will give you a copy of that article, which has all the details of everything that I've been explaining to you so far. How did we do this? And more importantly, what did all this cost? What you see here is the team of people that were doing all of these activities, controlling these mosquito populations on both these islands. These are not the guys that are doing just mosquito control. These are the guys that are doing rodent control. They're doing control of termites, cockroaches, everything else. So this is the pest control team on these islands. But if we look at what it took for mosquito control, the operation that I've just explained to you, then the cost for the first year of operation was $85,000. Of which about half was for labor costs, so the two guys that are doing the servicing, $4,000 for equipment and transport, so they needed a small buggy to go around the island, and then they spent $36,000 on consumables, which is basically the sugar and the yeast that was used for creating the carbon dioxide, as I explained. Now, interestingly, before we started with the trapping, the island had a contract with the pest control company doing the fogging, as I explained, and that costed them $91,000 per year. So not only did we replace the fogging that was no longer working because of resistance with something that worked, it was also actually cheaper than using fogging. And that's just for year one. And year one, of course, includes the cost of all the traps. In year two, if you start running, and year 3, 4, and 5, then you will only be looking at the consumables. So only the attractants for the traps will be the price. So in the end, it's going to be much cheaper as you go along. So that's one. Two, the other big thing that we've seen happening on these islands is that insect biodiversity started to increase. In other words, other insects, other than mosquitoes, started coming back. When I arrived on the islands of Soneva in March 2019 for the first time, I did not hear a single cricket at night. And if you're in the tropics, you should hear crickets at night. And they were not there because all of these insects had been killed by the spraying that was going on. But if you go now, 5 years later, you will hear crickets again. You will see bumblebees, you will see carpenter bees, you will see dragonflies, you will see a lot of insects that had disappeared because of all the spraying that slowly but surely find their way back into the ecosystem. And in fact, they bring balance again to the ecosystem. And as a result of that, you actually see bird life increasing. You see a lot more small little birds that prey on insects that are now on the island, and these birds were not there before. As a matter of fact, Soneva, the island that I've shown you, is now having beehives. It is producing its own honey, which of course could never have been done if they would have been fogging. So a big benefit that you're getting from replacing the fogging with trapping is that you're going to see an increase again in biodiversity and a more balanced ecosystem. Other islands, they then started to see the benefits of what was happening on Soneva, and they wanted to have the same thing. So the first island that expressed interest was the island of Duzetani, also in the Maldives, where we installed traps, have been there now for more than 4 years. Joali, a 5-star resort, again in the Maldives. Last year, I installed traps on their second island, which is called Joali Being. Again, 10 traps per hectare. And then we got to an interesting setting. This is the Barefoot Eco Hotel, also in the Maldives. But this hotel is not encompassing an entire island. It is only part of an island. And this was the first time that we started deploying the traps in high density, but not throughout the entire island. This is only part of an island. And still, I mean, these are clients of me until today. They're having 10 traps per hectare, and they're keeping their resort free of mosquitoes, or virtually free of mosquitoes, I should say, even though the surrounding areas have jungle and do not have any traps. But basically what we did is around the perimeter of the resort, we put traps every 10 to 15 meters. And in that way, we made a barrier of traps so that mosquitoes could not get in. And I will talk about the same thing a bit later. The same thing happened on an island in Indonesia, in a dive resort, where we only protected the hotel with a barrier of traps and not the surrounding areas. And again, this resort has been operating its traps for 3 years now, and continue to do so in exactly the same way as I explained. Summer Island, small little island, only 4 hectares, 10 traps per hectare, has its population down by more than 95%. So very happy. Nika Island, same story. Here we actually boosted the density to 15 traps per hectare. They've got 56 traps running on this small little island, have virtually eliminated their mosquito populations. And then we move to Banwa. Banwa is a private island in the Philippines near Palawan Island. Again, a 5-star resort that heard about what we were doing in the Maldives, expressed interest, and in July 2022, we went out there and we deployed 72 traps on that island. And again, we started monitoring very carefully what was happening with this population. And what you see here in the top graph, you see the average number of mosquitoes per trap per day. And as you can see, we started off with some 35 mosquitoes per trap per day. So that means, 72 traps. So that's close to 2,200 mosquitoes per day that were taken out of that population. But interestingly, and this is very significant, over a time frame of just 4 months, we hit 0. This was actually the first island beyond that small little island in the Maldives that I showed you, where people are living on the island, where there is villas, where there's guests coming, where we managed to eliminate a population of Aedes aegypti, so the yellow fever mosquito, and Culex quinquefasciatus over a time period of just 4 months. And you can see that here in the bottom graph, you can see how quickly the cumulative number, so the total number of mosquitoes that we trapped over time, how quickly we reached that point of 100% of the mosquitoes removed from the population. So that basically means that we have another island where we have eliminated 2 species of mosquitoes using mosquitaire traps, BG mosquitaire traps, at a density of 10 per hectare. So that island has now, it's actually more than that, it's 14 months. It was free of mosquitoes until, I should say, recently, when we had an outbreak. So recently there were construction activities starting on one of the villas on the island. A construction company came with a boat. They offloaded a lot of materials, building materials, and in those materials, there must have been eggs of Aedes aegypti that sparked a new outbreak. And that's an outbreak that fortunately we are bringing under control now. We are again at very low numbers, and soon I'm sure we're going to eliminate for the second time. This story, again, is a story that we have written up and published last year, just to show the world how we have been doing this on this island in the Philippines. Now, showing you quickly where we are. This is in the middle, you see the Maldives. So these are all the atolls in the Maldives, and these are the 11 resorts where currently we are operating these BG Mosquito traps, all with practically the same results, I should say. And globally, this is where we are. So we have 11 resorts in the Maldives. We operate in Thailand on an island. We operate in Banwa, which I just explained, Wakatobi in Indonesia. And last year in October, we started using traps in a 5-star resort in Madagascar. This year, we had Waldorf in the Seychelles, Cheval Blanc. I'm going there in the first week of August to install traps. Secret Bay in Dominica, so the Caribbean is now starting, and in October I'm going to install 300 traps on Mustique Island, also in the Caribbean. So basically you can see that the interest in using mass trapping for mosquito control with these Biogents traps is gaining interest around the world, and more resorts are interested in this. Now, I mentioned to you in the beginning that I was going to talk about moving beyond islands. I guess that most of you are not operating on islands somewhere in the ocean, but that you're operating with clients that are, living anywhere on the mainland. And basically what they want is they want a given area protected against mosquitoes. So that could be a resort or hotel. It could be a private property where people have problems with mosquitoes that they want to protect. And I think this is very interesting to mention here, because at the moment, what we're doing is we're experimenting on how we can use traps in a way as a barrier. So we stop mosquitoes from coming in from an outside area, and we protect everything inside that area. And that's what we call barrier trapping. Now, barrier trapping, a few years ago, Biogents already undertook experiments in France where they were putting a barrier of traps around a single property and actually managed to get Asian tiger mosquitoes inside that property practically down to zero. So this was the first indication that if we use a high density of traps as a barrier, you can protect property. And the example that I'm showing you here is an example from the south of Switzerland, where in March this year, we deployed 100 traps around a 5-star hotel. And we basically have traps here every 10 to 15 meters. And basically what we have been doing inside this hotel is inside the property, we do very intense source reduction. So we look for all the standing water, all the places that could potentially breed mosquitoes, and we either remove them or we treat them with a larvicide so that we cannot have mosquitoes breeding in those water bodies. And then we put the traps every 10 to 15 meters and around the entire property. And this is now working to keep mosquito populations inside the property below the nuisance level, so below the level at which the guests would start complaining. What we've also done, and this is also unique, is that we connected all of these traps either through the electricity, connecting them all, or connecting them all through carbon dioxide. So there's an underground conduit that is leading a pipe of carbon dioxide to all of the traps. So basically, here in the gray dot that you see here, this is where we have bottles of CO2 that are providing CO2 to the entire circle of all the traps from just one point. And the red dots are showing you the electricity points from which all of the traps close to it were connected. So this is operating as we speak, and we are very closely monitoring how the progress is going to be with this particular setting. But the interesting thing for you, if you're not operating on islands, is that this formula, this is something that you can offer to clients that want to have a smaller area protected against mosquitoes. Now, my last slide is the future of mosquito trapping, and that is that sooner or later, we're going to move into an era, into a period where we will have what we call smart traps, where we will have traps that will count mosquitoes, that will be able to differentiate mosquitoes as they get into the trap, that will be able to differentiate between the species of mosquito as they fly into the trap, that will be able to tell you, is it a male mosquito or a female mosquito when it's flying into the trap. This is what the future of mosquito trapping will bring us. And the funny thing is, that future is already there, because there is already technology that can help you to count mosquitoes as they are flying into the traps. And this is what is called this BG counter. So this is a device that can be installed on the BG traps, on the Biogents traps, and will automatically count mosquitoes for you without you having to do what I did by counting the mosquitoes by hand. This can now be done in an automated way. And the data that are being collected from this device can be transmitted to a cell phone or a computer so that you can remotely see how efficient your traps are in collecting mosquitoes. This is just the start. I believe that in future, we're going to get much more elaborate kinds of traps that will ever make it more easier for us as pest control operators to use these traps in a way to satisfy our clients. And basically, again, what I said is our clients, they're interested in having a mosquito-free environment. That's the main thing for them. For us, it may be research. For them, it is keeping mosquitoes close and down to zero. With those few words of today, I would like to thank you for your attention. I'm sorry that I cannot be with you. I wish I could be with you in Bangkok. Maybe I'm going to come to Bangkok in December. And if there's a possibility, I would love to meet with you and discuss more about this. So Pook, I'm handing back to you. Thank you very much all for your attention. And of course, I'm more than happy to answer any questions you may have. Also, finally, my email address at the bottom here. If you're interested, if you're having any questions about what I explained or any questions about how you may be using the Biogents traps in your particular setting, feel free to send me an email. I'm always interested in helping you out in how to use these products in the best possible way. Thank you very much.